Now I would like to give the floor to Mrs. Ifigenia Keramitsoglu from the Institute for Astronomy, Astrophysics, Space Applications and Remote Sensing in the National Observatory of Athens in Greece. She will make a presentation on the monitoring of surface water dynamics in wetland ecosystems using SENTINEL-2 satellite. Please, Mrs. Keramitsoglu.
Thank you very much. Thank you. Good morning and welcome to the final webinar of this project. Thank you also, Eleni, for referencing the work that was done at the National Observatory of Athens. I have the opportunity in this talk to speak a little bit more about the satellite services. In this presentation, the focus will be given in the final and I think innovative and impressive service of monitoring surface water dynamics in wetland ecosystems. This is using the new European satellites called Sentinel-2. This is a joint work with ECVI and Mrs. Fitoka. And I will start by saying that the aim of the satellite services was firstly to map the water and wetness dynamics and then to monitor these variables using the new satellite Sentinel-2 multi-temporal data for the whole BalkanMed transnational territory. So this was a very ambitious, I would say, task. And it started with the first step when Eleni earlier mentioned the satellite layer that was an intermediate layer where we mapped all the water and wetness areas in these 5 countries. And this was then given to the national authorities, and it was then overlaid with the national archives, and then after processing, it was the final set of polygons that was the polygons that were used in the monitoring. So then we used this updated set of wetland areas, and with these polygons we developed the monitoring service, the focus of which is the main part of this presentation. So as we represent the space and satellite world, just a few words for the participants who are not familiar. We are talking about 2 identical satellites called Sentinel-2A and 2B. They are operated by the European Space Agency, and they are part of the big program called Copernicus program. This is a European Commission program. By having a constellation of 2 identical polar orbiting satellites with the same imaging instrument, the result is that we have more frequent images over the area of interest. And this is very important when you are talking about monitoring a surface, and monitoring a surface that is especially so dynamic, that is, you know, like the water and the wetness in wetland areas. This is very dynamic. It changes constantly with season, but also from day to day. For example, if there is rain the previous day, so this is highly dynamic. So the fact that we are using identical constellation of satellites, it means that we have more frequent images of the areas of interest. The result with these 2 satellites is that we have an acquisition of new images every 5 days at the equator. And it is very important that it acquires multispectral data. That is, data coming from different parts of the electromagnetic spectrum. And this gives the opportunity to interpret the data in terms of wetness and water, and reveal this information that is inside the data. The spatial coverage of the so-called Sentinel-2, S2 stands for Sentinel-2, tiles used in the WetMainAreas is shown in this image, where you see the different tiles, 82 tiles in total. And if you think about the resolution of the pixel, the pixel size, that is the spatial resolution of the images, that is 10 meters. You can imagine that we are talking about an amazing wealth of information for these areas that is now systematically acquired and processed and then stored in databases. So I think that the point is there. And what the idea here is to have data. So imagine that each one of these tiles is somehow these layers of information. So this is latitude, longitude, and z-axis is time. So we're talking about data stacking, and then we calculate the relative frequency per pixel of open water or wetness. There are specific indices, spectral indices that calculate these variables. But I didn't want to make this presentation too technical, so I'm at your disposal to say a little bit more at the end, or provide the necessary references. One source is already given here, a publication by ECVI. So once you calculate the open water and the wetness per pixel of 10 meters, for these images, still we're talking about data stacking here, then what you do is you apply some rules in order to have a consolidated idea of what is happening in this wetland area regarding water and wetness. So the rules are like when you have, so you take the whole stack now. So when you have open water more than 85%, then you consider this pixel to be a permanent water pixel. And I'm not going to go through all the rules, but you see, you go from permanently wet to temporary wet areas. So you have this kind of classification. So the end result per wetland is this map that has taken into consideration all the statistics. But because this is so dynamic, it means that every time a new image is acquired above the area of interest, then these statistics are recalculated and you have a new result. Okay, so it is important to understand that this is a very dynamic system, and it gains value with time. So now, instead of showing a slide that I have prepared, I will go to the portal itself for the monitoring of surface water dynamics, and you will see here all the different wetland areas that were provided by ECVI and national authorities in the five countries of the program area. And so you see all the wetlands are there. We're talking about more than 8,500. I repeat, 8,500 wetlands. And the number here they are clustered. So when you move in, when you zoom in, then the polygons are revealed. So you can choose the area of your interest. I'm going to choose Lake Kerkini. And once you choose this area, here you see its code and also its name. You can choose one of these indices. So I'm going to choose the modified normalized difference wetness index. That is this one. And here you see all the images. Sorry, I'm going to move this. Here you see all the images that are acquired in this service, starting from 2017, because this service started in April of 2017, the first image for Kerkini, the first available clean image without clouds, was in June of 2017. And here you see all the available images, but you see the calculated, the water index calculated. So where it is blue, it means it is water, and you see the index values here. So the latest image that we have is the 13th of April 2020. This is the case for this polygon. If we move to another polygon, the dates will be different, because every time we have a satellite overpass, we check if there is a cloud image above the polygon of interest. And we calculate the index only, of course, when we have clear pixels. Okay, so for each one of those, you can actually, look at them, and you can actually click on each one of them. And then you see here, I have downloaded a zip file that has the GeoTIFF. So the managing authorities can have access to all this data, and they can have access to the data itself with a resolution of 10 meters. That is the index. And of course, not only this index, but also some other indices that we have calculated. And here at the bottom is the result when you take all those images and calculate the statistics. As I said previously in my presentation, when open water is above 85%, then for this pixel you have permanent water, like this blue here, and all this. It is really impressive to show you, to zoom in and show you the level of detail that appears in this data set. And this is the level of detail of 10 meters. So we have calculated this level of detail for 8,500 polygons, and this is updated every time we have a new satellite overpass. And you see here the dynamics for this kind of wetlands. You see here how it changes, how the water dynamics change, and the permanent water area changes. Okay, sorry, the open water area changes. Now I'm going, I'll just show you one example very, very briefly. Another example, this is an artificial lake. So here you see different different dates. So the latest image for this is Karlar Lake. Here is the name, Karlar Reservoir. The latest image is the 13th of May of this year. And you see how it goes back in time. And the first one was in May 2017. So we're talking about 3 full years, more than 3 years of data. And this is, of course, ongoing. And this is the consolidated result. So I'm going back to my presentation to finish up. With some numbers, because we think that the numbers are important in this case. So we are now in the era of big data. So monitoring water dynamics, I think that I have proven to you until now in this brief presentation that monitoring water dynamics is indeed a case of big data. So we have used 2 satellites, 3 years, 5 countries, 7 spectral indices, 8,637, this is the exact number of wetland sites. This is 450,000 clear instances, and this makes 6,300,000 objects in the database that we are managing here at NOAA. The number is huge. This is why we're talking about big data. It is 50 7 GB of data in a database, and this is really an amazing number for a geodatabase. This cannot be, of course, a conventional database. This is a geodatabase, and it has a very specific and very specialized implementation, so that it is as fast as you saw it. You saw it live. You saw how fast it responds, and it responds, and that you can access this data really in no time, in a few seconds, and have access to the data itself, all the intermediate layers in terms of these indices. So with this, I would like to finish my presentation. These are my contact details, and also if you would like, this is, I can put it in the chat later on, this is a video that was produced for the framework of this program that presents this service, I think, in a professional way. So I'm going to put this link in the chat so that you can watch it after the conference. So thank you very much for your attention, and I am at your disposal for any questions.
Thank you, Mrs. Keramitoglou.